Biggie Boy back with another video. Today we are looking at h2o2 from h2o's PWM controller. This is a beta test. Here it is all boxed up, LCD display on the front. The small holes on the bottom are for adjustments, frequency and current. Switch on the top is an override to bypass the pulse width. LEDs to indicate which mode it's in. And on the side here we have the two posts, minus common ground, minus output, and the positive post, 12 volts positive, with a good sized heatsink on the back. No cooling fan as of yet. I want to try it out without a cooling fan. So far it's been running fairly well without it. Here it is powered up. Voltage display on the front, and currently right now we have it in bypass mode, and I'm just going to switch it into normal mode and put it back in bypass again. Okay, let's open it up and have a look inside. I'm just going to disconnect the display for a minute here. It's the back of the display. And there's our circuit board. Most of it's surface mount. There's a couple of through-hole devices on it. That one there I've had to replace. Did have surface mount, but I burnt them out. I had a short to ground on one of the wires, kept frying the resistor, but I got that all figured out. Here's our pots, and in behind here is our large electrolytic capacitor, and in the back are our 4 MOSFETs for controlling the current flow to the cell. And here we are with the entire setup. 19 plate dry cell running in the background there. And currently the cell is receiving about 11.5 volts. And we're drawing about 20.7 amps at the moment. So the pulse width is controlling that and keeping it at 27 amps. And there's my new oscilloscope that I just got, so I thought I'd try that out. And here's our 2 channels. This is channel 1, and this one appears channel 2, and they're both set at a scale of 5 volts per line. And you can see this one is, channel 1 is quite taller than channel 2, yet they're both set at the same scale. Channel 1 is being measured at the pulse width controller itself, and channel 2 is being controlled at the cell. And I'm just going to stretch the wave out here, and you can see what the wave looks like on channel 1 at the pulse width controller relative to what it looks like at the cell. Quite a difference. Not too sure why that is. Not sure if the cell is filtering it out or what it is. Hopefully somebody can enlighten me on that. Something else I found interesting was when I stretched the waveform out, the frequency on the oscilloscope goes from about 500 kilohertz up to 1,000 kilohertz, and obviously that's got something to do with me stretching out the waveform. Still fairly new with oscilloscopes, so hopefully somebody can once again fill me in on, can explain why that's happening. Here I'm in bypass mode, and it just shows the waves totally bypassing the pulse width. Back on again using the pulse width. We'll switch it again. There we are, bypassed with it going straight through. Well, that's it for today. Stay tuned for another video coming up soon. And thanks for watching.